Hello and welcome to the Titus Timeout podcast series. Today's topic is pressure. You can't talk about HVAC systems without discussing pressure. There's a relationship between pressure and airflow, and you need to know airflow to make everyone comfortable in HVAC systems, so it's pretty important. Let's start with the pressure equation. Total pressure equals static pressure plus velocity pressure. When air moves through a ductwork, there are two components of pressure going on. Static pressure, which is exerted in all directions, and velocity pressure, which is only exerted in the direction of airflow. The sum of these is total pressure. The thing is, velocity pressure is hard to measure directly because there's a static pressure component going in the direction of airflow as well. So we usually use total pressure and static pressure to calculate velocity pressure. So velocity pressure equals total pressure minus static pressure. So now let's look at how we measure pressures in our ductwork. A pitot tube is used to measure pressure. A pitot tube is a tube with a hole pointed in the direction of airflow, which measures total pressure, and a hole perpendicular to airflow, which measures static pressure, because there's no velocity component in this direction. It's connected to a manometer, which is calculating the difference between the two pressures, which is velocity pressure. Knowing the velocity pressure allows us to calculate the velocity in the ductwork. The equation for velocity is velocity equals 4005 times the square root of velocity pressure. Now, knowing the velocity and area of the ductwork, we can calculate airflow, which is CFM equals the area times the velocity. So now let's look at an example. Let's say you measure a total pressure of 0.65, a static pressure of 0.3, and you have an 8-inch round inlet. So you know the velocity pressure is 0.65 minus 0.3 is 0.35. So the velocity is 4005 times the square root of the velocity pressure. Now if you work that out, you come up with the velocity of 2369 feet per minute. Now the area is pi r squared, so when you work that out, you come up with 50.26 square inches. Now we need to work in feet, so let's take our 50.26 inches and divide it by 144 square inches per square foot, and you get 0.35 square feet. So now the CFM is the area times the velocity, which equals 0.35 times 2369 feet per minute, and you get a CFM of 829 CFM. So now you can see that from knowing the total pressure and static pressure, you can calculate your CFM. So that's how pressure works. Thanks for taking a time out with us.